This is Math 99, Chapter 9, Lesson 3, Part 2 of 3 lectures for this lesson. We are going to learn how to solve exponential equations of type 1. There are 2 types of exponential equations. So, here we are. A type 1 exponential equation is an equation where both sides of the equation can be expressed with the same base. The ability to solve these depends on this uniqueness of b raised to the x power. In other words, if whatever x is, a base to that power is only going to be one number. It's not going to be 2 different numbers. So if I have this problem right here, 5 to the raised to the x is equal to 125. What I want to do is find a base that I can express both sides with. Well, 5 is already about the smallest base that I can find, but 125 is 5 raised to the 3rd power. Well, this uniqueness of b raised to a power, or a base raised to a power property, says that if those 2 bases are the same, then this expressions are the same, then those exponents had better be equal as well. So therefore, x is equal to 3. On the next one, number 2, if I have 4 raised to the x power equals 8. So let's do that one. And again, I want to raise both sides to the same base, but 8 is not a power of 4, as in the previous example, where 125 was a power of 5. So I need to find a different base where I might be able to express both 4 and 8. Both 4 and 8 are powers of 2. 4 is 2 to the 2nd, so another way to write 4 is 2 to the 2nd. It still has the power x on it. 8 is 2 to the 3rd. So when you have a power raised to a power, what do you do with the exponents? You will multiply them. So this is 2 to the 2x is equal to 2 to the 3rd, which means that now I have the same base on both sides. Those exponential expressions had better be equal. So therefore x is equal to 3/2. Now you can check this on your calculator and raise 4 to the 3/2 power and see if you get 8. But when you do put it on your calculator, make sure you wrap that exponent in parentheses. 4 raised to 3/2. And then press enter, and out should come 8. Here's another one. 9 raised to the x plus 3 power equals 27 to the x. Well, let's go ahead and do that one. 9 to the x plus 3 equals 27 to the x power. Well, both of these bases can be expressed as a power of 3. 3 squared is 9. The exponent is on 9 is x plus 3. And then 27 is 3 to the 3rd, and that is raised to the x power. Remember that when you have a power raised to a power, you will multiply the exponents. A lot of people go 2 to the x, but then they don't multiply the 2 to the 3. So let's write it down like that. The exponent being a group. So then I have that expression right there, having popped the exponents off. 2x plus 3 equals 3x. I have more x on this side, so I'm going to subtract. So if I subtract 2x from both sides, I end up with 3 being equal to x. So this means that if x is 3, 9 to the 6th power should be the same thing as 27 to the 3rd power. You can put each of those in your calculator and see if they're equal, and that's how you can check the problem, or check your answer. Let's look at example 4, which has 3 different problems on it. Each of these are similar. both of these, or all three of these, can be are type 1 problems. Both sides can be expressed with the same base. I'm just going to set them up and go ahead and let you work them out. So in this first one, 2 to the x is equal to 16. This is having been blown up a little bit. It's not very clear. But 2 to the x is equal to, what power of 16 is 2? 2 to the 4th. Now if you need a table of powers of 2, then on your calculator you can go y is equal to 2 to the x like that. And then in the table you'll have x and y, and 0 and 1, and 1 and 2, and 2 will be 2. 2 squared is 4. 2 to the 3rd is 8, and 2 to the 4th is 16. So you can scan down this y column and then realize that 2 raised to that power, 4th power, is going to be 16. So instead of 16, I'm going to write 2 to the 4th. That means that x is equal to 4. In this one, we did a one with 9 and 27 earlier, so 3 squared equals 9 raised to the x equals 3 to the 3rd. That's the problem that I worked on the other page. 4 to the x plus 3, again, 4 is going to be a power of 2. So write 4 as the square of 2. So 2, is that the one I worked on the previous page as well? Not quite. Okay, so 2 squared, the x plus 3 equals 2 to the 3rd. I think it was. Finishing it up again. So 2x plus 6 equals 3, a little bit different. Subtract 6 from both sides. So then 2x equals negative 3. And then x is equal to negative 3 halves. And yes, the exponent can be a negative number. Put this on your calculator to see if it works out the same. You're just checking to see if the decimals are the same. So there's example number 4. Now, you can do this one. We've done this one. This one looks this one looks confusing. You'll notice that 2 is a power of 4 is a power of 2, and 3 is a power of 9, but they're flipped over from each other. Well, do you remember how you can use negative exponents to flip something over? And the answer is yes, you can use negative exponents. So if I write this one as a power of 2/3, I will need to use a negative exponent. So the same equivalent problem is 2/3 raised to the x power is 2/3. Now notice that 4 is the square of 2, and it's the square, but I need to involve a negative exponent to flip it over. Check this on your calculator if you don't believe me. Make sure you wrap that base in parentheses, and also wrap that in parentheses, and see if you don't come up with 9/4. You might have to ask for the answer back as a fraction. So anyway, now I have my exponents, or my bases, the same. That means that x is equal to negative 2. Check it and see if that's true. Raise 2/3 to the negative 2 power. Again, your parentheses on your calculator matter, and see if that doesn't come out okay. How in this third one, how is a half related to 8? Well, a half is 2 to the negative 1st power. So then this problem can restate as 2 to the negative 1st to the 3x minus 6 power equals 2 to the 3rd to the x plus 1 power. Let's take it over here to finish it. Okay, so there's the problem, and then I have negative 1 times 3x minus 6 equals 3x plus 1, like that. Negative 3x plus 6, don't forget to distribute that negative through, 3x plus 3. Where do I have more x's? I have more x's over on this side, so I'm going to add 3x to both sides. So 6 is equal to 6x plus 3. Subtract the 3 from both sides. 3 is equal to 6x. Be sure to divide by the 6. So 1/2 is equal to an x. Check your answer back with the original problem. You'll have to use lots of parentheses to make sure that that gets done properly. Now, let's just look ahead a little bit to what we're trying to do, starting with lesson 4. We got one more lecture in 9.3. But here's where we can do this kind of a problem pretty easily with a type 1 problem. And the difference between a type 1 and a type 2 problem is that you can't express both sides with the same base. But this is asking, what is the exponent on 5 that would yield 30? I'll just give you a quick clue about the answer. 5 squared is 25. 5 to the third is 125. So the power of 5 that would yield 30 has to be a little bit more than 2. You can guess and check this and you can get close, but we need something that works a little bit better than just guessing and checking. So that's where we're heading with solving exponential equations, and this again is a type 2 exponential problem. Okay, yes, it would have to be more than 2 because 5 squared is 25 and less than 3. So that's why we have the invention of a logarithm, and that's where we're going with that.